This tutorial is for 4th grade, Module 5, Lesson 15. In this lesson, we're going to use area models, also known as fraction models, to compare two fractions. In my first question, I'm comparing 1/2 to 2/3. I went ahead and shaded in 1/2 on my first fraction model and shaded in 2/3 on the second model. Notice that I drew the 1/2 vertically in the first model and the thirds horizontally in the second model. We'll want to keep that pattern as we move forward. By just looking at the shaded parts, it's kind of hard to tell which fraction would be bigger. They're both pretty close. So what we're going to do is we're going to divide each fraction model into pieces so that the fractions have the same denominator. I'm going to start with my 1/2 piece. Since I'm comparing it to a fraction that has 3 for a denominator, or I'm comparing it to thirds, I'm going to draw my thirds on top of the 1/2. So I'm going to draw the horizontal lines that represent the thirds, just as in the model below. By drawing the lines, I've now divided the entire rectangle in 2/6. So instead of 2 pieces that made up the whole, I tripled that amount or multiplied it by 3, and now I have 6 pieces that make up the whole. And instead of having just one piece that was shaded, when we looked at our 1/2, I now have 3 pieces that are shaded, these 3 pieces. This tells me that 1/2 is the same thing as 3/6. Now let's go down to the 2/3. I'm going to follow the same process. This time, since I'm working with thirds on the bottom fraction, I'm going to draw my 1/2 on top of the thirds. Now instead of having 2 pieces shaded out of 3 that make up the whole, I doubled that. I now have 4 pieces that are shaded out of the 6 that make up the whole. So now the fractions we're comparing are 3/6 and 4/6. Well, that's easy to compare them since they're both 6 and I have 4 in one model and 3 in the other. The 4/6 has to be greater. And that proves to me that 1/2 is less than 2/3, or 2/3 is greater than 1/2. Let's go to the next problem. Here we're comparing 4/5 and 3/4. I'm going to start by shading in 4/5 on the top model and 3/4 on the bottom model. And here are my fractions. Now again, it's kind of hard to tell which one's bigger by just looking at the shaded portions. So we're going to follow the same process. I'm going to start with the 4/5 that my top model shows, and I'm going to draw the fourths on top of it because that's my other fraction. The fraction is dealing with fourths. So I'm going to draw horizontal lines across that match the horizontal lines from the model below. Now let's look at what we've done mathematically. We took the 4/5 and instead of having 5 pieces that make up the whole, we multiplied that by 4 when we drew the fourths on top of the fifths. Now we have 20 pieces that make up the whole. And instead of having 4 pieces that were shaded, I multiplied that by 4 as well when I drew the fourths on top of the fifths. And now I have 16 pieces that are shaded. You can see there are 4 rows of 4 that are shaded. So I have 16 20ths represented by this model. We'll go down to the fraction model below. It starts off as 3/4, and now I'm going to draw the fifths on top of the 3/4. So I'll draw those vertical lines that match the lines from the fifths above. And now let's see what we did here. We started with 3/4. when we drew our fifths on top of the fourths, we separated the rectangle into 20 pieces. And instead of having 3 pieces that were shaded, we multiplied that amount by 5 as well. Now I have 15 pieces that are shaded. This means I'm now comparing the fractions 16/20ths and 15/20ths. 16 is more than 15, so 16/20ths is more than 15/20ths, which means 4/5 is greater than 3/4. We're going to continue the process with these problems, only this time we're going to draw the fractions at the start ourselves. So here I'm going to compare 3/5 and 4/7. I'll start by showing my 3/5 on the top model, which means I need to use vertical lines to divide the rectangle into 5 pieces. So we have 1, 2, there are my fifths. And then I need to show my sevenths on the bottom rectangle, so I'll divide this rectangle into sevenths by drawing horizontal lines. And there are my sevenths. Now I just need to shade in 3/5 and 4/7 on the models. Now here are my fractions. In order to compare them, I'm going to start with my 3/5 and I'm going to draw the sevenths on top of the fifths. So I'll draw the horizontal lines to show the sevenths. And we'll record what we did mathematically. We started with 3/5 and we multiplied the number of pieces that made up the whole by 7, which now gives us 35 pieces that make up the whole. You can see there's 5 pieces in each row and there's 7 rows. So 7 times 5 is 35. And then we multiplied the 3 pieces that were shaded by 7 as well when we drew the lines across, which means we have 21 pieces that are shaded, 7 rows of 3. I'm going to move down to my lower fraction and I'm going to draw the fifths on top of the sevenths using vertical lines. And we'll record what we did there. We took 4/7. Instead of having 7 pieces that make up the whole, I multiplied that by 5, and I now have 35 pieces that make up the whole. And instead of having 4 pieces that are shaded, I multiplied that by 5 as well, and now I have 20 pieces that make up the whole. So the fractions I'm comparing are 21 35ths and 20 35ths. And 21 35ths is bigger, so 3/5 is bigger than 4/7. Let's do one more over here. We have 3/7 and 2/6. So I'll start by drawing the fractions on the fraction model and shading in the pieces. And here are my 3/7 and my 2/6. So we're going to draw our 6 on top of the 7s in the top model. So I'm going to use horizontal lines to do that. So we started with 3/7. Instead of having 7 pieces that make up the whole, I multiplied that amount by 6, and I now have 42 pieces that make up the whole. Instead of having 3 sections that were shaded, I multiplied that by 6 as well, and I have 18 pieces that are shaded. In the bottom fraction, I'm going to draw my sevenths on top of my 6 using vertical lines. So I started with 2/6. Instead of having 6 pieces that make up the whole, I multiplied that by 7, which will also give me 42 pieces that make up the whole. And instead of having 2 sections shaded, I multiplied that by 7, and I have 14 sections shaded. Now the fractions I'm comparing are 18 42nds and 14 40 seconds, which means 18 40-seconds is greater, and 3/7 is greater than 2/6. Now in our last section, we're going to compare the fractions, but we're going to do it without using the fraction model. We're going to think through the same process, but we're not going to draw the fractions out. Here's what I mean. If I start by comparing 3/5 and 5/6, if you remember, on the fraction model, if we had 3/5 as our beginning fraction and we're comparing it to 6, we would draw our 6 on top of our fifths, which means we would multiply the amount of pieces that make up a whole by 6. Instead of having 5 pieces that made up the whole, I would now have 30 pieces that make up the whole. And instead of shading in 3 of those pieces, we would multiply that amount by 6 as well, and that would give us 18/30. So 3/5 is the same as 18/30. Now let's do the same thing with the 5/6. If I started with 5/6, I would draw the fifths on top of the 6. Instead of having 6 pieces that make up the whole, I would multiply that by 5, and I would get 30 pieces that make up the whole. Instead of having 5 pieces shaded, I would multiply that by 5 as well, and that would give me 25 pieces that are shaded. So 5/6 is the same as 25/30. Now I can do my comparison. Since 25/30 is bigger than 18/30, 5/6 is bigger than 3. If I go to my next problem, 2/6 compared to 3/8. If I start with the 2/6, I'm going to multiply the numerator and the denominator by 8 because I'm working with eighths. So instead of having 6 pieces that make up the whole, I have 48. And instead of 2 pieces shaded, I have 16. When I look at my 3/8, I'm going to multiply the numerator and the denominator by 6. Instead of having 8 pieces that make up the whole, I now have 48 pieces. Instead of having 3 pieces shaded, I now have 18 pieces shaded. So the fractions we're comparing are 16/48 and 18/48. 18 is bigger than 16. That tells me 3/8 is bigger than 2/6. Looking at the next problem, if I start with 7/5 and I'm comparing it to eighths, that means I'm going to multiply my numerator and my denominator by 8. So 5 times 8 is 40. 7 times 8 is 56. So 7/5 is the same as 56/40. Start with my 10/8. This time I'm going to multiply the numerator and the denominator by 5 because the other fraction is fifths. That means I have 50/40. 10/8 is the same thing as 50/40. You may notice that both these fractions are improper, which makes sense because our original fractions were improper as well. I'm comparing 56/40 to 50/40. 56 is greater than 50, so 7/5 is greater than 10/8. And one more problem. You can see these are both improper fractions as well. I'll start with 4/3. Since I'm comparing them to fifths, I'll multiply my numerator and my denominator by 5. Instead of 4/3, I now have 20/15. So 4/3 is the same as 20/15. And I'll change my other fraction. I have 6/5. I'm going to multiply the numerator and the denominator by 3 because I'm working with thirds in the other fraction. So now I have 18/15. These are the fractions that I'll compare. 20/15 compared to 18/15. Well, 20 is bigger than 18, So 4/3 is bigger than 6/5.